Let's take a look at the Fibonacci sequence and the golden ratio in section 5.5. In 1202, Leonardo of Pisa, who is commonly known as Fibonacci, wrote a book entitled Liber Abaci that included a rabbit problem that generates the following sequence: 1, 1, 2, 3, 5, and so forth. And what you can see is that you add the previous two numbers to get the next number in the sequence. 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, and so forth. Now, this is the Fibonacci sequence, and there are patterns all over the place when you work with this particular sequence. So, for example, if you choose any Fibonacci number, and let's choose number 13, and square it, we get 169. Now, if we multiply the Fibonacci numbers on either side of that, 8 times 21, we get 168. And no matter what Fibonacci number you choose, this is always going to be true. The difference between the square of the Fibonacci number and the product of the two numbers on either side of it will always be 1. So let's take a look at 89. We'll choose 89 this time. All right, 89 squared, and let me get my calculator out, is 7,921. Now, if we multiply 55 times 144, those are the numbers on either side of 89, we get 7920, and the difference between those two results is 1. So that's just an example of one of the patterns that you can find with the Fibonacci numbers. Now, in the exercises, they actually show some more examples, and number 8 is the first one. And you can see they're using the Fibonacci's. 1 equals 2 minus 1. 1 plus 3 equals 5 minus 1. 1 plus 3 plus 5 equals 13 minus 1, and so forth. Okay, so the question is, following this pattern, what would the next number be? What would the next line be? All right, so we know it's going to start out just like the previous row did, so we'll put that in. Now, what's happening? Are we using every Fibonacci number as we look at this? I'm going to refer back to page 212 for my list of numbers. We're starting with 1, and then we use 3, 8, 21, 55. So we're only doing every other one. So that means the next one we want in our sum would be 144. Now, how do we get the number that we're subtracting 1 from? We start with 2, and then we move to 5. Then 13, then 34, then 89. So again, we're going every other one. So it looks like the answer of that, the resulting sum would be 232. But using the pattern, we can find it a whole lot quicker than we could with adding up the numbers. Okay, now what I'd like for you to do is pause the recording and you try number 10 on the same page. See if you can figure out the pattern. And then when you think you have it figured out, restart the video so we can go through it together. Okay, I'm assuming that at this point you've restarted the video because you have attempted number 10. Okay, and I'm just jotting down the first 3 squared plus 5 squared equals 34. 34, and then 5 squared plus 8 squared equals 89. So we have the first two Fibonacci's, and then we have the second one and the third one. Then we have the third and the fourth and the fifth and the sixth. So that looks like we're going to need the sixth and the seventh. The seventh one, 2, 4, 6 would be 13. Okay, and what about our sum? We're starting with the 2, and then we skip to 5, and then we skip to 13, 34, 89, so we want to skip 1. And hopefully you got that one right. 8 squared plus 13 squared equals 233. Okay, the golden ratio, which is related to the Fibonacci numbers as explained in the text on page 214, they show how they begin to form ratios of the Fibonacci numbers, and those ratios approach a number which is called the golden ratio. Was extensively used by the Greeks. They thought that rectangles made using the golden ratio were the most beautiful in the world. These rectangles and ratios appear in Greek art and architecture as seen in the movie Donald Duck in Magic Land. If you have a chance to look at that, you may want to, because it does talk about the golden ratio, or the golden, sometimes it's called the golden section or the golden rectangle. The golden ratio is approximately equal to 1.618, and its actual value is 1 plus the square root of 5 divided by 2, which you can see is an irrational number because of the square root of 5. So you may see the golden ratio referred to as the golden section or the golden mean. Both the Fibonacci numbers and the golden section or the golden ratio are used all over the place. The Fibonacci numbers are very prevalent in nature. The golden section or golden mean is very common in architecture and art. So and even in music. So you may want to look at Donald Duck. It gives you a little bit of a different perspective on what we're looking at in this section. Okay, I think at this point you're ready to watch the sample problems, which I believe I go over. 2 of the ones I go over actually are ones I've gone over here, but that's okay. I do go over some problems like 2, 4, and 6 in addition to that. So you may want to check that out before you move to the online exercises.